All right, everybody. Thank you for joining. Today's session, we're going to talk about end-to-end serverless apps with Google Cloud Run and CockroachDB serverless. This has been on my calendar for quite some time and been working with the Google team to pull this together. I'm really excited about this. I think when we first actually spoke about this, we didn't even have CockroachDB serverless. So it's been an amazing month here at Cockroach Labs. We're really excited about, everybody who's been out there trying and using CockroachDB serverless, but we're really excited to go out there and work with, other tools in the ecosystem, like a Google Cloud Run, and see kind of really, really deep alignment in approach and kind of how these things kind of come together to really kind of provide this end-to-end experience for people. And that's what we want to go through today. So, but before we get started, I guess a couple of quick bullet points. First of all, this is definitely intermediate. People like us to tell you what that is. We love questions from the audience, so please do ask questions in the QA and the chat, whichever you prefer. I think we're also streaming online at YouTube and I believe LinkedIn. So just on those platforms, we'll monitor the channels there and pull the questions into the session. So by all means, please do ask questions along the way, and then the recording should be available very soon after this. I think we get it up in pretty quickly. So with that, I'm going to come on camera, and Preston, I'm going to ask you to come on camera as well, if you might, buddy. There we are, and you look exactly like your photo, dude. I like that. Me, I'm grayer, and I'm not wearing a hat today. So everybody, welcome, and Preston mostly welcome. So Preston, you're a senior product manager at Google. Do you want to just explain what you work on and what your role is there?
Yeah, so I'm part of what's considered an outbound product management group. And sort of my primary attachment is to serverless products, but I do come from a solution architect background that was often involved in composing across different products at GCP. And so I really like to consider my mandate to look at building full applications on GCP where you're trying to leverage managed services as much as possible.
Yeah, and you've built a lot of custom stuff here for our demo today too. So thanks for all the hard work that's gone into this. I'm really excited about this conversation. Y'all, I'm Jim Walker. I'm Principal Product Evangelist here at Cockroach Labs. I don't build demos anymore. I just talk. To really smart people and have good conversations. And I have actually in the background, my friend Andy Woods has joined us as well from our product management team. So if there's any technical questions on the Cockroach side, we've got backup because the marketing guy can't answer everything. So thanks for joining us as well, Andy. So with that, let's just, Preston, I'm not going to show slides. I'm going to let you do your slides in a bit. And the demo definitely has some great stuff to get us set, but just to kick off the conversation, right? Just at a high level, without getting too deep into things, Preston, how do you define serverless?
Yeah, well, I mean, first of all, there's the joke, which I do subscribe to, right? Which is there's always a server, right? So there's always going to be a server. And so really then serverless becomes a level of abstraction that you interact with things that are encapsulated for you. So the real goal of serverless, in my opinion, is that as a developer, you should be, provided infrastructure in a way that lets you focus the most you possibly can on your application code, right? And I think that you can take this, all the way to the idea of function as a service, where literally it is the function signature that is all that your contract is to provide. And I think what we're doing in Cloud Run is interesting because we're sort of taking a step in the middle ground now, which is a serverless container model. So it's still serverless in that the idea of needing to provision capacity to manage scaling of that infrastructure as your app goes under load. It's basically, another analogy for serverless to me is, all of us have had to pick different sort of housing options. And so you can choose to go buy a plot of land and get an architect and build a custom house from scratch. Or you can buy a fixer-upper and put a ton of work into it, or you can find a place that's kind of move-in ready, right? And so for developers, I sort of look at serverless as being something that's move-in ready, meaning you still get plenty of opportunity to pick your furniture and decorate the place, but you're not spending tons and tons of time sort of with the dust of construction all the time, right? It's just that convenience over flexibility sweet spot.
Right. And expandable too, because God forbid you have a couple kids, i.e., maybe maybe your app goes viral on Hacker News and then these things needs to explode, right? Like, and maybe those kids move out and you need to scale back. And I think the elasticity of serverless is one of those things that I love as well. Like this eliminating the developers need to think about capacity planning and these sort of things. That's where I think it gets really, really interesting. And it's like, how do you become really straightforward? I'm really interested, and I can't wait until the day that we move beyond. I think of it more as like infrastructureless, almost. I don't think people really want to deal with load balancers and regions and AZs and any of that, right? And I think that's the ultimate vision. I'm excited about when it gets like that, because then it becomes real easy to I don't need to be thinking about spot instances, and I don't know. I can't size things for the life of me, Preston. So it's kind of cool. I think I do think the deeper and deeper I've gotten into serverless, the deeper and deeper I believe it is, an end game for us. Maybe there's always going to be an end game after that, but I think it's definitely the next level. What do you think has kind of held it back so far?
Yeah, I mean, I think there's a lot of myth busting still to do in the serverless space. I do see serverless as being sort of the thing you use when you have a trivial or sort of toy need, something really simplistic, something purely event driven. I think that is changing. I think people are realizing more and more production capacity workloads can be run on serverless. I think a lot of that has to do with, equipping the serverless platforms with more sophisticated features around privacy and security of the way auth works, the way networking to private networks works. All those things become unblockers to more traditional workloads that might want to run in a serverless context.
Yeah, I think we're seeing the same thing on our side as well, Preston. As CockroachDB serverless came out, it's like, oh yeah, what's it good for? Well, kind of hobby apps. Well, yeah, and maybe small production apps. And will it get better for bigger, larger production apps over time? You bet. And I see this kind of overtaking the whole thing. I think it's like me personally, I think once you see serverless, you can't unsee it. It's one of these things like, yeah, that's going to happen. And you kind of want it to be the thing that's going to be 3 years from now, but it's not there yet. And I think we're just all building to that point.
Yeah, I think, one of the areas where I think companies that are less ready to jump all in on serverless for mainline production apps can really get a great sort of playground for this space is internal apps, right? I think part of what serverless brings is that velocity of going from an idea to something that is working and running. And not having to spend as much time on getting it all set up and getting it running. So I think a lot of companies, there are tons of great internal ideas for utilities and things. And so using this pattern as a quick way to kind of build those apps will give people that exposure to this mode of development in a way that isn't necessarily going to trip up somebody and saying, well, how are we going to meet X, Y, or Z security review, or et cetera. So
I'm a believer in the agility of that sort of thing. People make fun of me. I kind of like these low-code platforms like Retool and some of the other ones that I think it's kind of cool. Like, yeah, for a quick little internal app, you bet, man. I can point it at our database and it actually creates an app for you half the time. Like, and then if you put some sort of simple functions behind it, I think it's it's agility, it's speed. And does it need to be super polished? No. Can you prototype? Sure. Can it work for internal? You bet. I think I agree with you wholeheartedly there. I think that's definitely one of those areas where people are doing it. But look at underneath the covers, right? With serverless, there's a whole bunch of complexity. I know you and I spoke a bit about this before we started. I know you had some slides prepared for this. Do you want to just start talking through that, Preston? I think it's a really good kind of jumping off point, and then we'll get into the demo.
Sounds good. Yeah, so I mean, it's interesting because I've actually been at Google Cloud now a little over 7 years, and what predated serverless or Google Cloud at Google entirely was Appen. So let me talk a little bit about how we kind of got there to where we are now. So really, it starts with this idea of that abstraction I was talking about, right? Let me as a developer not worry about all these things, even though I want all these things, right? I want rapid auto-scaling. I want this to be self-healing. I want it all pre-provisioned. These are the functional things I really want out of my infrastructure as a developer. So we have a core sort of internal engine that delivers all of these across Google data center infrastructure. And we, of course, bring in Google's kind of reach of network and protocols to those machines. And then we've, over time, essentially tried several different flavors of how to present and package this exact same core infrastructure to developers. And that started with App Engine all the way back in 2008. And so that predated GCP. It was from that time frame where serverless really meant PaaS, and PaaS really meant a sort of walled garden experience of something like App Engine or Heroku, right? This took batteries included to sort of the extreme. And it was very productive, but it was sort of, in the three bears mode, sort of too tight on restricting what runtimes you could use. You sort of used the built-in services or take your app somewhere else kind of thing. So it had its day, but I think we heard a lot about how people were frustrated by that restriction. Cut to sort of 2017 timeframe, credit where credit's due, AWS Lambda really kind of came up with this innovation of function as a service, right? This minimal developer contract of give me the entry point to my code, you take care of everything else. And we did our sort of take on this with Cloud Functions. Again, this was still limiting on runtimes, right? You had a finite number of languages and runtimes that were supported because you provided code. We needed to be able to kind of bring that code into a harness to actually invoke. And so there was a finite number of things that any platform could support as far as types of runtimes. And then, of course, Docker came on scene and blew up the world with containers as sort of the de facto way to package and ship the artifacts of your code. So 2019, we released Cloud Run, which really used the container. Now, all three of these are actually running on internally a lot of that same core similar infrastructure. So Cloud Run benefited from the history and experience of running very large, very sort of large scale applications on App Engine over the years. But this idea of Cloud Run being something that you can use any language, you can sort of use any web framework you want, you can package and build things portably and in a familiar way, but you get all those benefits of serverless in terms of not having to set up the infrastructure. And if I were really to kind of capture what is Cloud Run in one slide, this is how I'd show it, right? Which is basically you bring a container, you know what that is, and we will run it on all that fun, shiny hardware that Google keeps in giant buildings. Like if you simply want to take your container and bring it to us and have us run it, Cloud Run is the most direct way to do that. And the other thing that I think helps give some sense of what is Cloud Run is that when we use the term container, we're often using it to refer to kind of two different things. One is that serialized representation of your code packaged as layers that you sort of push to Docker Hub or push to a registry. And that's a very static thing. But the container is also this runtime isolation, like when you run the container. And so you can think about taking your code, and Cloud Run is like this sort of super cloud multi-docking port. It brings all of these capabilities to your running container. We're not obviously going to go through all of them, but I'll just kind of list some of these here. So when you run a container, it runs as a sort of a Google identity. We'll show a little bit of that. It brings all that, like you're saying, I don't want to think about load balancers. Well, we've got a built-in sort of global front end that can route traffic to you, and I'll show some of the traffic splitting. You get to, configure with environment variables, and it's got some built-in observability. So really, it's this idea of like, you have, all of these things which just by running your container sort of attached ports and attached capability. So from here, I think I'm going to just launch into a quick example of showing you what this experience is like. Go ahead, Jim. Yeah.
Hey, Preston. Yeah. I had like two questions actually. So is Google Cloud Run global? I mean, is it global infrastructure? I mean, because it's like the beauty of GCP. I mean, Google it's massive, and it's not just like one beautiful building with shiny infrastructure. It's like, massive amounts of hardware, right? Is it global?
It is a regional service, but available in all cloud regions that Google is in. So it's global in the sense that you can deploy services globally, and you can take services and put them behind a global load balancer and have a globally running service. The failure mode, obviously in any cloud infrastructure, you want certain blast radiuses. So a lot of Google Cloud products are divided into either zonal resources or regional resources. And Cloud Run is regional, which means it is multi-zone. And so without any real configuration on your part, a Cloud Run service will run in multi-regions. And my understanding is that aligns perfectly with Cockroach Serverless. So that if you sort of pair those two together, one thing that's really nice in a serverless mode is when you pair serverless things together, because really, if you want to realize the benefits of serverless, you don't want to have one part be serverless and the other part not, right? You collapse to the lowest common denominator of your toil. And so using fully managed offerings kind of across your application requirements is really the best way to realize the value of serverless.
Yeah. Cool. And I guess that leads back to this kind of whole self-healing nature of it, right? You pick your failure domain and let the infrastructure kind of self-heal along those domains, right? So
yeah,
cool. All right, cool.
So yeah, I'm gonna race through some of this stuff. Of course, people, including Jim, stop if you want to ask for quick clarifications, but I'm gonna just show you what some of this experience is like and show you that without provisioning or managing anything here, I'm going to deploy a new service in Cloud Run. So I'm going to select a container image I already have run, sort of pushed up to our registry. Just use this as an example. And I'm going to use, again, here's where we pick like which region. One thing we've introduced recently at Google is more visibility into carbon impact. So you can sort of use carbon sort of footprint as one of your decision-making factors. So, one region might be lower in carbon than another. Yep. I'm not going to go through all of the various configurations. We're going to just kind of get something deployed. And as this is deploying, what's happening is we're staging all of the container materials we need in our infrastructure. We're setting up a front-end route. We're assigning it a public URL with HTTPS. And you'll see that actually, let me. I did something to myself around the demo. I'm gonna create it in a region that I've already used. So this is every time you first deploy in a new region, there's a little bit of bootstrapping that we set up. So let me just. Luckily, the nice thing about demo in Cloud Run is it's pretty dang zippy, and so that means that things. You can do this live and not be sort of, often when I've demoed technologies in the past, you have to kind of have your pre-baked version and your ready to show version. So there we go.
I mean, it's like one of those fishing shows where there's a scuba diver underneath the water with a cold. Yeah. Anyway, sorry.
Fish on the hook.
Exactly.
So here you can see I redid my demo here, and I'm still already at a point where I have a public-facing URL. This will just return a simple JSON string, and you'll see what we're going to do with this now, because I'm going to take this URL and sort of off screen here, put it behind some load generation. Give me a sec to do that. And while I'm doing that, I'll also then switch and bring up a visualization of something that you can't see as easily for Cloud Run kind of behind the scenes, which is a visualization of how Cloud Run scales out the number of containers. So this is something that is happening in the infrastructure that you can't really see. So I've written this sort of custom visualization to have every new container that we spin up report itself to this tool. What you're seeing right now is that we're sitting here at 0 containers, which means there's no traffic going to that new service. And therefore, we won't run or bill for anything. It's a full scale to 0 service. And if I send it some traffic, what you'll see is requests coming in will scale out of a container in this case. And then when the traffic ends, we'll scale it back to 0. Now, this is something that in a Lambda or Cloud Function case, one serverless unit can only handle 1 request. In Cloud Run, we actually have the ability to deploy multiple, or actually handle concurrent requests in a single container. So this will actually give me a chance to fix another thing and show you sort of the speed of this, which is that in Cloud Run, the resource model is based around two kind of primary resources. One is a service, which is your long-lived thing that has a URL, and then multiple revisions, which are sort of these immutable snapshots of every code change or configuration you make, right? So we'll deploy a new revision, and I'm going to change that concurrency down from our default of 80 to, let's just say, 2. This, again, will be very fast to deploy. And if I go back to the visualization and hit it with some more traffic, just going to give it a second to deploy. I'm going to trust that that was done. You'll see that now I'm going to scale out many more containers because any one container can only handle 2 requests at a time. So what you're seeing is this high elasticity of the service. We can quickly scale out the number of containers. It looks like we hit out to about, almost 25 plus containers, and then right back to 0 as soon as the traffic is down, right? And again, nothing in this is running in any cluster or provisioned infrastructure that you have to manage. This is just something we have ready to kind of bring to bear for you. Any quick questions?
Yeah, I have them. I definitely have one. What is the start time for one of these containers to spin up, right? Because I think, that's kind of one of these things about serverless, and I know our team is working on this like crazy, right? Because with a database, it's your initial transaction. If that thing sits dormant and you got that start, I presume you guys spend a lot of time there, right? Trying to get that
and
down.
At the end of the day, it is one of these shared responsibilities, right? Because we want to give you, the developer, the flexibility of containers, your own container init time is going to be part of that total cold start. Cold starts are a thing. We have not magically figured out how to do away with them entirely. We have a couple ways to mitigate them. One is this concurrency model, right? Because once a container is warm, we don't have to start a new container for every request as we would in a Lambda or Cloud Function kind of sense. So that helps immensely. We also, for some of those first landing requests, you can have sort of warm standby containers that are built at a lesser amount, but are still kind of kept in standby mode. There's a bunch of things about the way we actually can throttle the CPU down between requests and change that. I'm not going to get into all of those aspects. I did want to show this next piece, which is around, and just kind of introduce it, which is this traffic management piece, right? So part of the benefits of serverless is that you can get these things deployed really quickly. I think the goal in any, high functioning DevOps culture is to do like high velocity product evolution of whatever you're shipping, right? You want to keep getting new capabilities, new features. I've seen you guys at Cockroach do this with your own serverless offering, right? Like you want to be able to kind of improve in place. And one of the things you've got to balance against that velocity is the safety of not messing up the experience for your users, right? And so one of the tried and true ways of doing this is some sort of progressive delivery where you have a new version and you want to sort of start exposing users to it. Maybe it's alpha users, but maybe it's just a percentage of your production traffic. And so traffic management is this idea that we're going to have a new version. This isn't that visible here, probably. That's a green version. And I'm going to start at 10%, then roll it to 50%. If everything looks good, I'll switch it all the way over to 100%, right? And that would be the basics of how you do traffic splitting. I'm going to go ahead and show you this really quickly using the same service and revision. So I'm going to go ahead and edit this and deploy a new version that I'll call a green. So I have an environment variable that's used to kind of give me my line color. I'll call this one green. I'm going to uncheck this box here to say I want to ship this to our infrastructure, but not route any traffic to it. So that'll deploy this new revision with 0 traffic, right? I can then manage traffic and say send 10% of traffic to it. And I'm going to show why this is relevant soon in a schema evolution case, but I'll just kind of set the basics of what this capability is. And so I'm going to send more load to this, but for a longer period of time. And I'll go back to that visualization. I can manage all my tabs. So what we should see here is that now I've got a green and a blue version of that app serving traffic at the same time. Cloud Run is doing all of this traffic management for you. you can see that to serve 10% of the traffic obviously takes fewer containers than 90% of the traffic.
Yeah.
So it makes it really easy to sort of at this point in a real world sense, I'd be managing, my key performance metrics. I'd be making sure we're not getting bug reports from users. Once everything looks good, I can go ahead and say, okay, actually, I want to make this, 100% of the traffic. We're ready to roll that out. I can actually then see this traffic change be applied in real time right here. So now my old blue version is done. It scales to 0. The green version scales up. We're serving all the traffic. All's good. All right. So those are just the quick introduction to the Cloud Run sort of capability stuff. I want to now get into the Cockroach kind of like how these things play really nice together. And the truth is, I think serverless as a term gets used way too much to refer to the serverless stateless compute, right? And people talk about stateless apps. There really aren't any stateless apps. Like that's one of my pet peeves when people talk about stateless apps, because what app do you use day to day that has no state? There's no such thing. And so I think serverless gets overly attached to these serverless compute stateless platforms when really you want a serverless app. And that means you need data. And where are you going to put the data? Because an app without data just isn't that interesting, right? And so what we want to show here is how we can integrate these two really quickly. I think also with an eye towards security, right? Because we want to have, Jim and I were talking before we went online here about how really this is a time where serverless is kind of turning a corner and being more viable for more production quality apps. And part of that means up-leveling the security mode in serverless products. So let's go ahead and run through this. I do have a repo. We'll be sharing the link to this. The repo has the steps to do this all on the command line. So I'll kind of reference some of these steps from this README, but then I'm actually going to show you some of it in the console. So the very first thing I'm going to do here is I'm going to create an identity for my service to run as. And I've actually already done this. I'll just show you this here. And this is basically something that my service can run as its own identity. So here I have the Cockroach demo service account, and that's a robot service account that I can run my Cloud Run service as. The next thing is if I go through here and I want to, first I can show you that I can just develop this app locally, right? So here is my example app. It's a very, very simple Flask and SQL Alchemy app. If I sort of show you the key point that I want to work with is that I've set this up to use a DB URI environment variable, right? And luckily, if I go into my Cockroach cluster, it's very easy for me to go get this URI. If I go just here to connect, and then I have my connection string here, and I can just grab this and use this as my environment variable. So I've done that locally. And that lets me test my app locally first, right? So I'm just going to run this file now. It's running. I have a port forwarded here through my IDE, so I can sort of open that up through a browser. And I've got an app running. Now, for reasons I'll show you later, there's already some data in this table that I'm using. But I've got, you can see here I'm connecting to localhost. So that's all good, right? Obviously, I need more than just working code to get this running in Cloud Run. So backing up, that's where one of these first security steps is I want my app to have an identity. I create that first. The next thing I want to do is I don't want to take that connection string, which has my password, and put it in my code. So 12-factor app over 10 years ago said, hey, use environment variables. Don't put secrets in code. And up until recently, that really has been the best you could do. What we wanted to do in Cloud Run is sort of go a step further. And so Google Cloud has a secret manager service. And what that lets me do is manage secrets in a way that are logged and permissioned. So here I have my connection string here as a secret. And I can look at the permissions of who can access the secret. And I can allow my Cockroach demo service account to read the value of that secret. And if I look at another secret, like my secret message, you'll see that that service account can't read other secrets. So it's a very much a least privileged design on the serverless side. I'll go ahead and for the sake of time, I've already built and pushed the container, but just to show you really quickly, essentially with Cloud Run, you can build containers kind of just the same way you're used to building containers. In this case, it's a simple Python container. So I get my requirements in there and I pip install them. I am doing one step here, which is I'm using the Cockroach cluster cert. This is not a secret per se, right? This is how do I tell my app to trust the cluster that I'm connecting to. So this is just very similar to the kind of green padlock you'd see in a browser when you connect to your bank, that you want to know that the bank you're connecting to is the bank you expect to trust you're connecting to. So this way I'm being very explicit to say, again, this is something I was able to download from my Cockroach cluster. This is something that isn't private because it's using asymmetrical keys, right? This is a public key, so it's not really a secret in that sense. So I can include that in my container. But for the service, I want to make sure I'm using the secrets manager integration we have. And let's just go ahead and get this running on Cloud Run now. So what I'll do is I'll go through here. I'm going to create a new service. I'm going to select the Docker image that I'd pushed earlier from this on, I'll just use this one. And I'm, again, going to leave most of these the same, but now I am going to go into the advanced settings to show you the variables and secrets. Because what we've done here is we say, I want to reference that secret. I want to reference the connection string. I want it exposed as an environment variable of DB URI. And what this does is my code doesn't have to change at all, right? I don't have to use a client library to call a cloud API to go get a secret out of some special Google API for secrets. I simply use this integration to take that fully managed secret store and expose it at runtime as an environment variable to my code. So that's all I need to do. I'll just continue this. And soon we should get that URL. And if it's all working as it should, we should see something pretty much like what we're seeing on the localhost side. And there you go. Looks like we've got a tie, which is interesting. We can make sure there we go. So I've got a live app served in a fully managed compute platform with an HTTPS URL, making a secure connection both at the transport level, because this is a TLS connection to the cluster. In this case, the cluster itself is running on Google Cloud. So I know I'm actually in a very high performance network environment, right? I'm staying on a Google network. And all of this is sort of fully managed. I never went in and set up a cluster either from my compute layer or my data layer. I've got this running, it's scaling, that's great. Now, of course, I personally think tabs are more important. I'd like to be able to sort of express that, I'm really emphatic about my choice. So I really want to change this application. And sometimes changing an application, will require changing my database schema. Before I get into that, Jim, any questions about what we've seen so far?
No, dude, I'm sorry, Preston. I didn't see all of this. This is awesome. Like literally you just did everything without ever configuring a server or a database. Like, and that's pretty, this is great, dude.
Yeah, and both of these, just to repeat, both of these are regional, right? They're highly available. Right. They're both going to scale. So load, like I should expect this site to be able to support, unforeseen like successes. That's the goal, right? Everyone wants to be able to sort of, I see a lot of developers do a lot of premature optimization for success, which not everything's going to be the thing that goes viral, right? So you can spend a lot of time instead of getting out to market with an idea, preparing for a scale, which you may or may not, right? Like market fit and realize and getting that fast iteration in product development is the key. And so here we're just taking that concern about scale off the table. Like I can just focus on the app.
Yeah, it's funny. So one of our DevRel people, Adrian Howard, who works here at Cockroach Labs, we were talking about this. It's like there's a Kent Beck quote. It's like, make it work, make it right. And then I think we're adding like, make it scale. Like make it work, just make it work. Like just make the thing work and then make it right. Okay, secrets management, everything else, like, and then make it scale or make it right. Maybe there's some schema changes. That's what you're about to go through, right? Like the iterations become really important. I think this type of environment, this is incredible, dude. This is awesome.
So if you go to this repo, you'll see that what I've done is I actually am managing the schema change, like you might manage changes to your code as tags or branches in something, right? So I have a schema change branch, which has some updated steps on the README. And what I'm going to do now is I'm going to use the kind of connection tool in the Cockroach binary that I have installed on my development machine to connect to my database. So I have that here, right? And I can do things like look at what tables I have. Of course, this is a very simple setup. I have my votes. I can describe what my schema is in the votes table. So here you can see it's, again, pretty straightforward. I've got ID, time cast, whether it's spaces or tabs. And now I'm just going to issue alter table. Now this I'm doing directly in a console. But of course you can use schema migration frameworks, et cetera. But the thing is here, my app is still serving traffic and it's still reading and writing to this database. This schema change was made without any downtime to the database. You can see now if I go ahead and describe, I've got a new column, nothing changed. Now, there are ways that you can alter tables in a way that can disrupt your app. So you do want to think about, the right way to evolve an application with the schemas, often sort of adding columns, making changes to your app, removing them. This is actually something Google has captured well in the way we do protocol buffers as a way of describing APIs. Protocol buffers, if you're familiar with them, it's kind of like JSON schema, but we always use an append style of adding fields. No, Jim, if you want to add to that.
Yeah, I was going to say, we get into these conversations all the time with customers because online schema changes present a different approach to what people are typically used to, right? Typically, it's like, okay, make the schema change, bring the database offline, bring the database back on, put the application back on it, test it, see if it works. Hopefully everything's right. Well, like you just said, you just basically change the underlying schema in CockroachDB, and you now can actually start changing your application to use. I like this. I love the idea. You just append and then remove later. Like, don't just change the thing. Like, and I think that approach, that iteration to actually understanding how you actually want to change something is something we get into conversations about all the time. And it's strictly on. I think it's just one of these things. Like when you do get into this kind of distributed systems and distributed thinking point of view, like, I think you all at Google just think like this, honestly, Preston. The rest of the world doesn't think like this yet. And I think it's like, it's second nature for you all. Of course, you're like, oh, it's like we do in product, like, yeah, of course. The rest of the world doesn't think like that yet. Or, well,
I mean, I think one thing, especially with databases, right? I think we're still in a world where we over ascribe the cost of storage, and storage has really gotten so cheap that if you need to have a duplicate column of a different type to make the migration of your app easier, that's a lot safer way to change a type on a column than to try to rewrite data into that, like to change the column in place under the same name.
That's right. So
you can like, changes to code are pretty easy. Storage is cheap. It's much safer to duplicate, an integer that was accidentally initially deployed into a string type and you want to make it a proper integer type. Just make a new column as opposed to try to transform a column.
Right. It's interesting too, Preston. I get in these conversations. We used to normalize databases because we were worried about the cost of the storage. We're normalizing database today because the speed, right? Like, and it's like, yeah. And I think that's one of these nuances that I like. An online schema change is, just add the thing and remove it later. It's fine. The database is it's never gonna go down. You just have access to that. I think it's kind of one of those. It's an interesting concept how things have changed over the past couple of years.
Yeah, So let's go through, and I want to basically mash up my schema change I just made online to the cluster to this traffic splitting piece. So I've got a code version, so I've got a tagged container image here. I'm going to do this don't serve all the traffic thing right away and deploy that. I'm going to show you another feature of this kind of these revisions and the routes we can manage, and that is I can add what's called a revision URL to this new version. And I'm going to call it emphatic. And what this does is this gives me a special sort of shortcut URL, right? My main service is still running at this URL, but now I have sort of an alpha tester URL that I can open. And you'll see that the look and feel of this is going to be a bit different. I have this new checkbox that says, I'm emphatic about my choice. Like I'm going to vote for tabs emphatically. And it shows that here, like an emphatic vote was made for tabs. Now I still have the old version of the app still running at the same time, reading the same data. And there's the vote. It doesn't show that it was emphatic. It degrades gracefully for this new feature. But here we go. And so now I think, okay, we've done some internal Q&A. I want to start exposing this to people. I can do this managed traffic. Now, just for now, I'm just going to be aggressive. I'm going to go 50-50, right? And what this means is once this routing change is made, again, nothing's being redeployed on the actual app side. This is purely a data plane configuration in our fully managed data plane. So now I'm at the main service URL. And if I just hit reload, you'll see it's kind of like a coin toss, right? I might get 3 or 4 reloads of one version versus the other. But now half the people are getting one experience, half the people are getting the other. And that really brings me to this next point, which is that one of the things about serverless sometimes that takes people some getting used to is this sort of, you're not always easily like I can't shell into a container and debug what's happening, right? So you really want good observability in a managed system because you're going to be relying on those windows into how something is performing. So if I look at my cluster example, part of the reason there was data in the database was because I've been sending some load to stuff already. And this is just looking over the past 30 minutes or so. And if you look at this, you can actually see here, I've got inserts that were coming from my load generator, and they dropped off. They went from, some average of 0.2 requests per second or inserts per second to kind of close to 0. And so this might alert me that maybe I pushed some bad code, right? If the app seems to be behaving across the kind of simple tests I have, tests miss things sometimes, right? So sometimes your visibility into this is going to be looking at the monitoring and the metrics. And here we've got a set of metrics. I can track how if I, again, not a lot of data to put tabs versus spaces, but I could see a spike in storage consumption, for example, that might tell me, maybe we're writing something into the database that we didn't mean to be. All of these are things that you need the visibility provided by the managed service because you're not getting into under the covers. If we look on the Cloud Run side, we've got some metrics around request latencies, request counts. All of these are built-in metrics. I didn't have to sort of do anything. For logging, we take, no matter which language you wrote your app in, anything that was sort of standard out gets written to cloud logging where you can do filtering and querying on those logs. So I think this sort of is rounding out the serverless narrative, right? Is that you really want to be able to then also operate these things in a way that gives you a sense that if incidents do come up or you have bugs or there's some sort of thing, you have that visibility into what's happening on the managed platform.
Preston, that's it? That's all? Like, come on. Dude, that was awesome. That was amazing. And by the way, can we have like stateless versus, stateful apps? And can I have like a bunch of emphatic votes for like, apps with databases, honestly? Like, I remember when I first, I was early days at CoreOS, and when I first started there, this whole Kubernetes thing, it's like, oh, it's for stateless apps. And I couldn't even get my head around that, honestly.
Right.
But I love this demo, Preston, because you show kind of how the two worlds together, like the database and the application layer, working together in unison to scale up and down together. The alignment, I think, is the real power here, right?
Yeah, and I mean, again, I'll say it again, that, and I've heard this directly from some of the customers I work with, that they really realize that power of serverless when their whole app is serverless.
Yeah.
If I had to go and manage a cluster for a database and then use Cloud Run to connect to it, it's kind of like, I'm setting myself up for a lot of effort and toil somewhere. At some point, you start to kind of feel like, oh, I'm, it's like it's maybe a weird analogy, but like, energy states, when you took high school chemistry and they talk about electrons at different energy states and they collapse down, right? As soon as you're collapsing down to one energy state, you kind of start to feel like, well, we're in the swamp. I guess we're living in the swamp. So that's why I think these things do play really nice together. I think it's also really about bringing in, a broader audience of developers. I mean, I work with lots of folks who love Kubernetes. I've used it myself for years and years, but a lot of customers that I talk to, there's a limited kind of talent pool out there, right? And it's hard for companies to hire and onboard as many developers who are going to be experts at all of that YAML, when really you want your developers to be focused on just the app, like let's get the app shipped, like, because it's ultimately features you ship in the app that matter to your own customer service or product goals, right? Like your end customers don't really care what's delivering the app as long as it's available and scaling and still performant. So
yeah, I mean, Preston, it's like I want to wake up in the middle of the night worrying about an algorithm for some functionality, not worrying about some infrastructure problem that I'm having, right? Like, and that's the thing that, when I first saw, and correct me if I'm wrong, but I think Google Cloud Run runs on top of Knative, correct? Is it part of it?
That is part of it, but let me clarify that, because it can be one of these misconceptions. So when I showed that layer of core serverless infrastructure that powers App Engine, et cetera, that is all running directly on internal Borg, directly on Google hosts. What we've done with Knative is essentially the phrase I like to use is we have an open interface to a proprietary implementation. So Knative is a spec and a reference implementation of that spec that you can deploy yourself to a Kubernetes cluster. And Knative is part of what defines this resource model of services and revisions and allows things to be scaled to zero in a cluster, because most Kubernetes resource models don't support a scale to zero, because something has to be around to wake it up, right, from zero. So that's what Knative is in a cluster. I can show you really quickly that we conform to the spec. And if I actually go here, you can see that I can export Knative compatible YAML and bump the resolution here a little bit. So anyone who's done anything with Kubernetes is going to recognize this KRM style, right? I've got a Knative type. I've got all the metadata. I've got things like how much, which container image I'm using, how many. All of this is kind of Kubernetes and Knative compatible. But the only way that we're able to scale out as many containers as rapidly is we're running this directly on Google proprietary systems and infrastructure.
On Borg itself, yeah.
Yeah.
Yeah, and if somebody doesn't know what Borg is, you just Google Borg. It's funny to say Google Borg.
Yeah, well, it's essentially the predecessor. It's the thing that led to Kubernetes as an open source project, right? Our internal version of Kubernetes, essentially, that we run all things from Gmail to search and everything else on.
Yeah, it's pretty awesome. It's pretty amazing. Actually, there's some really good like Google Scholar documents on this and stuff. Go check it out. I always try to tell people to go to that because Google does such a good job of getting this stuff out into the world, Preston, like the how this actually works, which I like to expose as much as I possibly can, because I think some of the work that the engineers have done within your team there and just within this team beyond, it's phenomenal. It's I think this is life-changing stuff because the speed at which you're able to actually do these sort of things, we want to be the database part of that for sure. You know what I mean? I think it's always a key piece of it, but even Cockroach Labs and CockroachDB is spawn of Google Cloud Spanner, right? So kudos to the Google team, because I think it's actually moving everything a lot faster. It's just amazing, actually. So,
well, and when we first chatted, we thought about, okay, well, what kind of work would we have to do to get these things to integrate and play well together? And it turns out, we didn't have to do that much. So what's really nice about that is, I've always been a fan of the connection string and the DB URL kind of pattern. And I was able to take some sample code I already had access to for something else that was using Flask, and I didn't have to really change it all to get it to work with Cockroach, which is great. Like, it was just out of the box. It just worked from a portability point of view. So yeah, I think people in general, as a developer, what you want is that sort of insurance policy of having something standard based and open in some way. But if you can opt to have a managed version of it that performs really well without it being part of your own toil budget, great, because I've got my escape valve if I need it. It's just, Postgres and containers. But hey, if some companies can help take care of the day-to-day side of this for me, then it's just one less thing I'm not worried about.
I love that description of this demo. That's exactly right, Preston. This is just Postgres and containers with a whole lot of special magic underneath to really actually help eliminate the entire need to do any sort of operational toil underneath it. Like, that's, yeah, I mean, kudos to the team. I just think the foresight and some of the thought put into this is just really incredible. So it's great to see it come this far, dude. It's really cool. So there was one other question I think I had somewhere. Is there any standardization on containers at all, or is it just like, this is going to run any container, you just dump it into the service? Is there any like requirements?
Yeah, we do publish what we call the container contract. So it'll run any OCI container. The container contract contains things like, hey, here's the maximum amount of RAM we can assign. Those kind of parameter limits that we have. Now, a lot of those are in motion. So we've changed that contract over time. We keep the documentation up to date. But for example, you need to open a port, and you need to kind of help us communicate which port your container is listening on so we can deliver requests. A question came in from YouTube. I see that CockroachDB serverless does not support distributed.
Yeah, I can dump that one.
All right, Jim, yeah, that's all you.
Yeah, I mean, right now, the architecture of CockroachDB and the full version is, well, there's distributed execution of every query, right? It's happening across multiple different nodes in that. In the current version of Cockroach, that's actually on single node from what I understand. And I'd have to get deeper into the details of that. I would actually, I would encourage this person to join our community Slack channel and actually raise that question there. Unless I don't know, Andy, did you want to talk about this, about distributed execution in serverless? I know you're here too. I forgot that I could phone a friend.
Yeah, so the super short answer is that serverless involves a SQL pods that sit on top of a shared KV layer, and we use one SQL pod at a time right now to to deal with various queries. Whereas in and that's fine, because we scale up the CPU and compute resources that are necessary to handle any kind of query automatically in the process here. Now, in CockroachDB dedicated or in a self-hosted environment, you would have multiple nodes. Each of those nodes would have CPU. And so we'd want to spread a query out across each of those nodes and take advantage of the CPU resources that aren't necessarily being used right now to be most efficient with them. And so we don't do that exact same thing here in serverless. We are looking into being able to use multiple SQL pods in order to scale up and parallelize work in more detail, but it's not quite needed in the same way that it was a beneficial thing in CockroachDB dedicated or self-hosted.
Yeah, I'll just share that, so welcoming Cockroach, the serverless landscape here, in that sense that you just shipped your first serverless version. We shipped Cloud Run's first version 2019, and Cloud Run today hardly resembles what we shipped. Like, we've added so many things, and that's another thing. When you kind of buy into a managed offering like this, you're getting an evolving and improving product in place. You don't, like, as you all add more capabilities to this in Cockroach serverless, I don't have to go and do a big upgrade iteration. Right? Like, I don't have to go and patch a bunch of my systems to take advantage of improvements you're going to be making on my behalf, some of which I may not even see, right? Some of them are going to be user facing and others are not. And that's certainly what we've we've been doing in Cloud Run is it's an always moving and improving thing. And I think that's part of the value proposition when you get into this sort of serverless mode is my wife, we drive a Tesla. My wife loves to tell friends at dinner parties, like how the software updates, right? Like it's made software updates as a thing exposed to a whole lot of non-technical people out there because their product is improving without them having to do anything or buy a new version, right? Like I would never expect I'm going to have to go buy a Cockroach serverless version 1.5 to get the upgrade. So those kind of things are really nice about the hosted offerings.
It's the beauty of the modern world in this services-based environment that we all live in. So these managed services. So Andy, thank you very much for that. That was the first time I've ever had to like phone a friend. That was awesome, dude. So I'm so happy you're right here, buddy. So we are at the we are at the top of the hour. Preston, again, thank you so much for doing this today and all the work you put in the demo. It wasn't a lot of work though. It was easy, right? No, I'm joking. It was you know, it's relatively easy. I mean, it's again the alignment between kind of serverless database and serverless platform and kind of what you're all doing. It just works really well. So I'm going to dump the Git repo into the chat one more time. Oh, that's Google Cloud Run. Actually, that's if you want to go get started using this stuff, you can head over to that URL, and then I'm going to dump your repo in this as well.
Yeah.
But with that, yeah, I mean, you know, you're just P-T-O-N-E, P-Tone.
I'm P-Tone pretty
Twitter.
much all the places. P-Tone at Google, P-Tone on GitHub, Twitter.
Yeah.
I mean, I've had ptone.com since 1994, so
Awesome.
That's the handle that has stuck.
Yeah, I have a unit. I'm James, Jaymce. It's on my thing, but like, no, I have people ask. I'm like, well, it's a Chicago pronunciation of James, which is my name. Like, it's like the Bears, James. You know, like so. Anyway, same thing, Preston. But again, thank you so much for doing this, Preston. This is really that was an amazing demo. That was awesome. So one of the best demos I've seen in a very, very long time. Just super compelling. So thank you so much.
You bet. And thanks for all those who attended. Hope you have fun playing with these technologies.
Yeah. And thanks everybody for taking their time out of their day. I know how busy days can be. And we really